Testing. This is Professor Thomas live streaming. I will be right back. Right back. I'm going to put on a little bit of music. I'm getting this this video ready. And we're going to go over the practice final exam solution set. Let's make sure we're doing it all right. I will be right back. It says Thomas. We're here live and direct. All right, we're going to go over some of the solutions. I got the solutions all over the place, so we're just going to go over some of the solutions. Let's keep it down. I'm streaming right now. So listen, let's take a look at some of the solutions now. Some of the solutions that are not on this document have been worked out on a separate space, because there was limited space. All right, and the final exam has been completed. There's actually 15 questions. It covers a wide range of them. The points have not been set. I don't think they're all going to be equal weight, but they will range from 1 point, 2 point to 3 point, depending on the parts and the breakdown. But it will be stated when we take the exam how much each question is worth. But because there's 15 questions, we probably can squeeze. We're probably going to try to squeeze about 40 points total on it. So we're not going to be able to push it to 100. There's just not that much. The breakdown of the points, it's just not that much. But there will be half-point deductions, the minimum infractions are half-point deductions up to full point and all credit. So it's either half point, -1, -2, or all, depending on that. So these problems are pretty straightforward. You find the weight. Where it says find an equation of variation, and it actually tells you the type of variation there was. We actually studied two different types. We studied directly proportional, and we studied the inversely proportional, as one varies inversely instead of directly. But for this one, directly proportional, you actually have to write that equation. So you need to write this equation, but you got to know what K is. So the actual equation, the answer is m equals 0.179e, where your K that's been rounded off to 0.179. So you had to find your K, but how do you get the K? Well, you use one of the points. Use what you're given to find your K. So here's your original equation. You're plugging in the weight of the moon, when the Earth, and then you're actually using your algebra to solve for your K, and you plug that into your formula. And now, based on your equation, how do you get the astronaut's weight? Well, you just plug the weight of the Earth into your variation formula, and that will give you the weight of the moon once you multiply it by your K. So it varies directly. So it's just a multiplication of the K. I hope the quality of this video is good. Just set it up really quickly. I didn't even do any mic checks or tests. I don't even know where my volume levels are at. I probably could set them up a little higher, so I apologize, but hopefully you can follow me still. Evaluate the limit, and let's see, if we plug it in right now, we're going to have 0 over 0. So you got to simplify it out and then plug it in. Once you factor it and simplify it and plug it in, you're getting 2. Here, take the derivative of -1 over 2x squared. Probably best approach is to bring the x squared up. So that's -1/2 out front, and then times x to the -2. And then use the power rule. You're going to bring that -2 down and subtract 1 to it. And when you bring -1/2 times -2, it's just 1. I don't have my pen on me, but I could freeze it. Put the 1 in there. And the new power is -3, and now you simplify it out. It's 1 over x cubed. Final answer. Is h continuous at x equals 3? Why or why not? You go through the steps. H of 3 is 7. That is true. So h of 3 must be defined. The function must be defined for h of 3. It actually is 7, so that's proof. We get a real number. It's defined. Secondly, the limit as x approaches 3 must be defined, and it is true. We use the second rule for this. In order to get the limit of h of x, you have to test what does the value approach as it approaches 3 from the left and as it approaches 3 from the right. And the only function that allows us to evaluate those values, that limit, is this guy, which is really x plus 3. It simplifies to x plus 3. So you're plugging that in, and you're getting 6. So the limit is defined. And then the third step is to establish continuity at a point, is that the h of 3 must be equal to the limit of h of x as x approaches 3. And it turns out that they're not equal. So this function is not continuous at x equals 3. And it's because of the third property that the limit of h of x is not equal to h of 3. It was almost continuous, but it failed right at that point. Average rate of train is pretty straightforward. Pretty straightforward. I'll let you guys look at that. The hint for this was to graph it. Graph the puppy. Take a look at it so you can see what the domain and range is, and you can even identify the mins and the maxes. This actually shows you how we actually get the critical values of plus or minus root 2. I took the derivative of f of x, simplified it out, got a single rational expression. Actually, it turns out here, the single rational expression simplifies to this, and it's only going to be 0 whenever the top is 0. So I just take the entire top and set it to 0, and then solve for the x. You're getting x squared is 2, so x could be plus or minus root 2. Okay, now root 2 is 1.41 approximately. So it's a little bit more than 1, but less than 2, and a little past 1, but less than 2. And I tested points along the interval. We split it up into regions from -2 to this, from this to this, and then from this to 2. And we're getting negative, plus, minus. And that lets us know that we have the derivative is negative here, which means the slope is going downward. The function is actually going downward, and then it shoots up. So that means there's a minimum, and then it's up, and then shoots down. So there's a maximum at this point. And there's our relative min and relative max at these particular points. Again, after that, to get the point of inflection, I would say graph it, because the formula for the second derivative, the formula for the points of inflection was to find the critical points of the second derivative and see what happens if there's a maximum or whatever. And the truth is, where the second derivative is undefined, it's going to be extremely difficult to get the second derivative of f prime. Hey. If the music is becoming annoying, you could type. Let me see. I got a chat in YouTube. I have a chat. So if I type something, if the music is too loud, let me know. And if you're watching this live, you should be able to chat. If there's a question that you want me to go to, or if I happen to skip over it, you let me know, and we can go back to it and spend a little bit more time on it. I don't know if you can see the chats or not, but you should be able to. This is a good question, all right? We have the position function. This is basically tells us the distance after t seconds. The distance is in meters, but it doesn't say it. So we have the formula, and the first question is how far the stone has traveled 5 seconds after being dropped. So this is a formula that lets us know the distance that the object is being, the stone is traveling, how far after it's been dropped. And all you do is plug 5 into your formula. So find S of 5, and that's 25. 25, okay. And then we do 25 times 4.905. And what do we get? Well, 25 times 4 is already 100. So it's a little bit more than 100. All right. And so we're getting 122.65. B, how fast it is traveling 5 seconds after being dropped. So not only do we want to know, well, first we wanted to know the distance, but now we want to know how fast All right, that's velocity. Now to get the velocity formula, you'd have to take the derivative of the position formula, the rate, to get the instantaneous rate of change. So the derivative of this formula is 9.81 times t. We do the power rule, 2 times 4.905 minus 1. So we're getting 9.81 t, and there's our velocity formula. Now all we got to do is plug 5 into there. We need to find v of 5. And v of 5, that's 9.81 times 5, all right? And you multiply that out. I don't know off the top of my head. I know 5 times 9 is 45. 5 times 80 is 405. So we're doing 45 plus another 405, so 49.05. See, what's the acceleration after it's fallen for 5 seconds? Well, that's to get the acceleration formula. That's actually the second derivative of s, or the derivative of v. So take the derivative of v and plug in 5. Well, it's a constant number. So the derivative of 9.81 t is just 9.81. So it looks like the acceleration is constant. It's this rate, 9.81, and that's it. That's its acceleration. You don't have to worry about the sign and all that. If it's negative, because it's falling, it's negative 9.89. You're not going to worry about that. You simply just take the derivatives and plug in the values. Find the equation of the line that's tangent to the graph at this point. So here it is, pretty straightforward stuff. Nothing too out of the ordinary right now. We took the derivative and plugged in -1 to get the slope. See, it looks like a 6. -6x squared plus 5. Plug in that -1. -1 squared is +1, so still -6 plus 5, that's -1. So the slope is -1, and we have a point. X coordinate is -1 as well. What about -5? Where did that come from? Well, if you plug -1 in to the original function, you can get the y coordinate. Plug -1 in, you're getting a +2, and then -5, and then -8. So that +2 minus 5 minus 8 is -3 plus 8. That's -11. I think that should be -11. I think we might have already done this problem again because the sign was off. And then you plug it into your function here. So that point, -1 and -5, turned out to be, I don't think it was accurate. If we plug that in, we're getting 2 minus 5 is -3, and then -8. So it should be -11 there. Let me check on some of the other documents. Okay, no, it wasn't there. Let me check this one. So yeah, you might want to make a note that this problem was redone correctly. X was -1, so we plug that in there. We're getting +2 minus 5 minus 8 is -11. So there's our point and there's our slope. And we use the point slope formula, and we're getting y equals -x minus 12. Determine the vertical asymptotes. Well, the vertical asymptotes will only occur when the denominator is 0. So you take the denominator, set it to 0, solve for all the x's. So it's at x is 0, x is 4, and x is negative 4. Find the absolute max and absolute min. So basically, you got to find all the critical values and the endpoints. And you got to use the endpoints. The endpoints are critical values as well. So you get your critical points and you use the endpoints and plug them all into the function to see which one's the greatest, which one's the lowest, and that'll be your min or your max. So we took the derivative here. We're getting 3x squared minus 3. 3x squared minus 3. We set it to 0, and then we solve for the x. So x is plus or minus 1. So we have 4 points. -1, 1, -2, and 1.5. So we have them all lined up right here. This goes all the way down. Those are the points. -2, -1, 1, and 1.5. We got 3.3. We got 0. We got 4. We got another 0. So there's 2 minimums, but the absolute max here is at -1 and 4. Because when we plug that -1 in there, we got 4. So that's the absolute max. We rejected this because they were tied. They had the same y value. We excluded it and we just focused in on this, the absolute max. Same scenario, but there is no endpoint. So in our case, we simply just took the derivative, found our critical point, plugged it in, and determined if it was a max or a min. There's a bunch of different ways to do that. I mean, if we take the second derivative, we'd get a -2. And that means then that it's the second derivative is negative, which means there's a maximum. And the actual point was 2, 4. We just took the derivative, set it to 0, got our critical value, that's 2, plug 2 into the original to get the y, and there it was. There was a maximum. You could get clever and graph them as well. It's always a good idea, and see what it's looking like. The minimum, there is no minimum. This function goes all the way down to -infinity, so there really is no minimum. (13). Let's look at an example of this one. So, yeah, I mean, we have this problem here. It's we have a cardboard 8x8 square, and we want to know, we want to cut the corners so that we want to maximize the volume. We want to turn it into a box. And in order to turn a square into a box, you have to cut out each corner, and you have to fold it up. You fold it up, fold it up, fold it up, fold it up, and it becomes a box. And we want to know, how much should we cut to make the box its maximum volume? And so we know one whole side is 8, and this whole side is 8. We want to know how much to cut, so we're going to let how much we cut it to be x, because that's this part x. We have to maximize x. We have to figure out how much can we cut to make it a very big box with the most volume. So, and the X is actually a little square in itself. X is all the same size. So so the formula for the volume of the box is going to be the volume of the box is going to be the length times the width times the height. So like if we were to fold it up, fold it up, fold it up, fold it up, the height would be X, the height of the box. The length of the box would be 8 minus 2x, because there's 2 x's that got cut out. So this piece from here to here is 8 inches minus 2x inches. And then the width would also be 8 minus 2x. So the volume is equal to the length times the width times the height. All you have to do at this point is multiply it out. I don't think we did it really fast, but when you multiply it out, you got the FOIL method, and then multiply it out, and then take the derivative of v. Well, once you have a polynomial, it's easy to take the derivative. Just power rule, take the derivative and then set it to 0, and then solve for it to get your critical values. I think we got like 2 and 4. I'm like so curious about this right now too. Let me see if I'm a lefty, but I'm holding the mouse and I don't have my pad to write on. So, it's not even gonna let me do that. Oh, let's add a new page. I don't even think this one's on there. I'll do it though. FOIL it out. That's 64 minus 16 minus 16. So this is a gift. Total gift tomorrow. Total gift. Plus all right, I'm going to simplify this and distribute the x. So now it's time to take the derivative. That's just 64. Minus 64. X. Plus I'm going to switch it around and set it to 0. I'm pretty good for a lefty. I'm writing with my right hand. Skills. You got to set it to 0 because we want to minimize this. We want to know where is the instantaneous rate of change 0. That's going to be either a max or a minimum. So the instantaneous rate of change is 0. Let's find what x value will minimize this, maximize this. I need to solve this quadratic. I'm going to factor out a 4. Actually, if I factor a 4 out, what's that going to do? I'm going to pull a 12 out. Too bad I can't take a 12 out. If I factor a 4 out and then divide by 4, it goes away because we divide it. So if I pull it out and divide, the 4 gone. So I'm going to get now 4 into that. That's 1 in 16. Oh. I'll be honest with you, I'm not even sure about the factorization of this. I use the quadratic formula. I don't know why this doesn't seem right. Could be right. What if there's lag? We gotta pick this puppy up. That's 8. So we're getting 16 plus 8 is 24 over 6. And then also 16 minus 8 is 8 over 6. 1 and 2/6 is 1 1/3. Now we have to reject the 4. The problem is we reject the 4 because the cardboard is 8 inches long. And if we cut a 4 inches, one X, the other X is going to be 4. We're not going to even have a cardboard anymore. 4 doesn't count. We cannot use 4. So X, and just plug this into your V. This will be your answer. Once you figure it out, once you take 8/6 or this is how many inches we should cut. I don't even think it's on there. Here's the total profit function. Profit is cost minus, actually, revenue minus cost. So once you have your revenue, your cost functions, and you want to know how much for part B, how much is for each 50 units, even for profit, you plug it in, just regular old C of 50, R of 50, P of 50. So that's on page 9. Now for part C, the marginal cost, revenue, and profit when 50 units are produced, you need to take the derivative of each one. C prime, R prime, and P prime, and then plug in 50 for each one, and you'll be good. This problem we did do, 15. Don't forget about your dx. Dx is 0.2. So dy equals negative 3x, 4 minus x squared plus 4 minus x cubed dx. But I should replace that 0.2 inside here. Get rid of the dx and put 0.2. This is not here right now. For part A, they just want the what's dy equal to. So that's dy. But for B, find dy when x is 5 and dx is 0.2. So you plug 5 into the x and plug 0.2 into the dx. 16 was worked out as well. I did it really fast on a separate sheet of paper, so it's right here. Hey, this is actually a differential equation. This wasn't fair. It wasn't. This is very high level mathematics, but it turns out the equation, the solution to this differential equation is y equals p naught e to the kt power, where p naught is the initial value. And they give us the initial value. 0.07 is our k, but the initial value is 100. So this is part A, this is part B, and this is C. This is the solution to A, B, C. When time is 1 and the initial is 100, you're supposed to evaluate it out, okay? You have to use a calculator for this. Use a calculator. What's e to the 0.07 power?
I've got this for you on second power.
No. What's the exponential to the 0.07 power?
These two skills might be able to help with that.
What's e to the 0.07 power?
These three skills might be able to...
Give me a calculator.
You can ask me what you'd like me to calculate, such as, what percent of 2,400 is...
Well, enter this into your calculator to get the final answer. In what time period will an investment be doubled? Figure it out and approximate it. We're talking years. So ln2 divided by 0.07. I don't have a scientific calculator available unless I go on the internet. Let's move on. Okay, so for 18, you're for A, just plug in 3 weeks here, get your answer, plug in 40, plug in 80. Find the rate at which the disease is spreading after 20 weeks. So you need to find n prime of t and plug in 20. In prime of t and plug in 20. And we actually did this. Now, this was a tricky one. We beam the denominator up to the top. So take the whole bottom and bring it up, but you got to change the sign to -1. So the whole thing's in parentheses to the -1 power. And then you can do it. Oh, actually, I think we did the quotient rule as well. You can take the derivative by the quotient rule, now that I think about it. Very messy. We're getting like 4.63 or something. This piece again, it has to do with graphing it, and I basically said don't really worry too much about explaining this type of problem right here. Basically, it levels off. This is a limit growth rate type of problem, but if we're talking in terms of a university setting, this model is not. I mean, students are not. Are not. This is an assumption that the population stays the same across this period of time, and we know that in a university setting, the population doesn't stay constant. During the holidays, spring breaks, people are out. Yeah, this was actually a pretty good problem. 22.3% of the Dead Sea Scrolls had already lost its carbon 14, which means 77.7% had it. And so that's what we used for our initial value. And then also the half-life here, the K is here. It was a good problem. Another good problem here is your formula. You solve for P, so divide both sides by this to get your P naught initial value. I will point out this one's pretty tough. I just did the derivative with respect to x, f of x, and got that. This was pretty straightforward. These are all right here. Also for 30. This is the function, f of x comma y, x squared plus y squared there. This is the function. Find the relative maximum or minimum values of this. So first, boom, 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 boom. Find all of those derivatives, partial derivatives. Then you set the two, the partial of x, partial of y, set them to 0, and you'll get a systems of equation. And you solve that system for x and y, and that's going to be your critical point. This is three-dimensional type stuff. Now you plug it all into the big D. Find D. Fxx times with the critical point times Fyy. The critical point minus Fxy, the critical point squared. Plug it in. D is greater than 0. D is 3. D is greater than 0. And also Fxx double prime is greater than 0. That means from the D test, F is a relative min at this point. And the value of it is at -3. I think this was a good review, especially considering what the test looks like. The test has been completed. 15 questions and you're home free. Last I checked. 15 questions and you're home free. Grades are looking excelente as well. We're going to end the broadcast here. If you still got more issues, I'm going to be up for a couple more hours. Reach out to me. I'll try to get into the room as early as I can. So if you want to come into the room beforehand, I'm going to try to open it up. And the correction is that it's actually not from 10 to 12. It's from 10 to 11:50. Oh. Apologize for that. I should have sent the word out for that. Hey, no problem, Marcus, man. Hey, good job, man. I'm rooting for you, and it's gonna feel good to be done. Talk to you guys later, all right? Bye.